Welcome to the workshop. I want to take a look at section 7.5 today, strategy for integration. And what I'd like to do is I'd like to take a look at the entire section and present a brief version of it. There's 4 examples that we take a look at, and the purpose of these examples is not necessarily to complete the integration, but rather the purpose is to say how are we going to do this, or what method are we going to use, and give recognition to we might not be right the first time around. So again, I want to give a brief presentation of the section, and then if you would like to see the calculation of these integrals, or the evaluation of these integrals, then you may take a look at the additional videos that are posted. But for this section, really it's just a matter of trying to decide what method you're going to use, which is a very important section because this is exactly what you're going to have to do on the exam. When it comes to the Chapter 7 exam, it's going to be several integrals that you need to evaluate, and you just have to use the appropriate method to evaluate those integrals. So you have to recognize what situations you have and what method for integration you should use. So let's take a look at section 7.5. The first thing to notice, right, is it's the strategy for integration. So there is an outline of the strategy for integration. And in this, let's see here. If you want to follow along this and say, all right, what's number 1? What's number 2? What's number 3? What's number 4? If you want to do that every single time you find an integral, that's fine. I think that it should be a little bit more natural than a process. Essentially, we're simply trying to evaluate each situation. But if you want to follow these, that's absolutely fine. So when we find an integral, when we're given an integral that we need to evaluate, we might first simplify the integrand if possible. Okay, cool. That may or may not make sense to do, of course. Making it more complicated might actually be helpful, so that's maybe useless. I don't know. Okay. If it makes sense to simplify it, simplify it. That might lead you somewhere, it might. Okay, you move on to the next step. Look for an obvious substitution. If you get something that can be rewritten as the integral of u du, then yes, right? If you can find something that's easily rewritten as u to a power du, so you're just applying the power rule, yes. And definitely at times you're going to find things that work out nicely to give you exactly the form of something that's on our formula sheet. If we scroll to the right page of it, right, if we can find a u substitution that's going to give us one of these basic integration formulas, then yes. Okay, so you need to be familiar enough with these to recognize when you have something that looks like this. So we look for an obvious substitution. Sometimes it's not completely obvious, but we look. So if there's nothing obvious that we should simplify, if there's nothing obvious for a substitution, then what we might do is go ahead and begin looking at classifying what kind of integral we're taking a look at. Maybe we have something that's powers of sine and cosine, or powers of tangent and secant. In the case of this textbook, they also gave rules for integration involving cotangent and cosecant. I don't think you really need those, but you can take a look at those as well, and that's fine. Okay, so is it a trigonometric integral? Excellent. A trig or trig approach, right? Is it a rational function? If it's a rational function, then partial fractions may very well be a good way to go. Not always, but it's definitely something you should try. So you try partial fractions. It may even be something that's not quite a rational function, right? That's polynomial divided by polynomial. It might be something that looks like it could be a polynomial divided by something that looks like it could be a polynomial if it were the right powers, right? If we were to, oh, look, everything is x to the 1/6 or the 6th root of x to a power. Right, perform the substitution, let u equal x to the 1/6. I think we did this in the previous section. So we can find rational functions somewhere and apply partial fractions. So that's a possibility. Integration by parts, right? If we have the product of a polynomial and a transcendental function, bam, almost every time you're going to want to use integration by parts. Sometimes it's just the transcendental function itself. We also saw that in the case of integrating, let's see here, that was hyperbolic tangent? No. And let's see here, arctangent, maybe that's what it was. So that, yeah, I think that's what it was, integrating arctangent. So there are times when it's not the product of a polynomial and transcendental. Sometimes it just has the transcendental. And then when there's a radical, right, it depends on the form of a radical. When we have u squared plus a squared, or u squared minus a squared, or a squared minus u squared, or that can be written in that form, we would want to use some sort of trigonometric substitution. Sometimes using these particular rules can be beneficial, though it is not always common, right? Letting u be the nth root of something, or letting u be the nth root of some, right, some linear function, or just some function in general. That doesn't always work out in our favor, but it can at times, and it's something that you should pay attention to. All right, so after you've done that and you found that none of these things work, you go ahead and try again, because your first attempt isn't always going to work. We don't have a lot of time in this class to look at the wrong way to do things. I'm not sure that it's always beneficial to start an example the wrong way just to highlight that sometimes things don't work. So we've done it and I've mentioned it, but we don't do it often. But it's something that very easily and frequently happens. So what does that mean for us? Well, that means in your homework, you're probably going to try something, it's not going to work out, and then you're going to try something else, and maybe that one will. It might take 3 tries, it might take 4 tries. Chances are it won't take 4 tries unless you're really not sure of the approaches, or maybe you're taking the approaches the wrong way. So you got to have a good knowledge of section 7.1 through 7.4. Of course, all of our previous Calc 1 content as well, and our Calc 2 here, where we're talking about integrals of exponential functions and logarithmic functions. So we need to be familiar with quite a bit in order to find, or in order to evaluate these integrals. So if none of these work, right, we try again. We try substitution, we try integration by parts, we try to manipulate the integrand because simplifying it wasn't actually beneficial. We needed to write it differently. A lot of times related to a previous problem. I try to do several examples. I've tried to give you guys quite a bit to look at. So make sure you're using that. Make sure you're using the practice problems, most of which you have solutions for, so that's helpful. And then use multiple methods. There's definitely the case where you've got to use multiple methods. We've seen that before already. Or the same method multiple times, right? That's what tabular integration is. That is the application of integration by parts multiple times. So that method in itself sometimes requires being applied multiple times. All right, so let's leave this video here. Let's step back, take a break, pause for a moment. And in the next video, we're just going to briefly look at all 4 examples, briefly discussing the methods that might work. And then as some supplemental videos, if you want to see them worked out, we will do that. All right, so I'll see you back in the workshop very shortly.